Hello everybody, hello dear students. Today we are going to contain chapter 4, which is the electrochemistry, which we have started before. The electrochemistry, as we have said, is a branch of science that studies the exchange between the chemical energy and the electric energy through spontaneous or non-spontaneous redox reaction. The spontaneous holds the galvanic cells and the non-spontaneous holds the electrolytic cells. We have studied before the reactions and the experiments that discuss the redox reaction, and we have started the galvanic cells, and we are going to continue that way in that session in also our different way and in our smart way. Let's start. Today we are going to contain what we have started the last session, and we are going to contain our explanation to chapter 4 to the electrochemistry. We are going to discuss here in session 2 the electromotive force and how does we choose the zinc rod to be the anode and the copper rod to be the cathode. Okay, we are going to study here the electromotive force and the standard hydrogen electrode. Okay, at the last session when we are studying the galvanic cell, we have chosen the zinc rod to be the anode and the copper to be the cathode. The zinc rod is the rod which will be oxidized and the copper is the rod which will be reduced. And why did we do that? The zinc has higher oxidation potential, so it will be the rod which will be oxidized, and the copper rod has lower oxidation potential, so it will be the rod which will be reduced. And how does we know that? We are going to study here the electromotive force and the standard hydrogen electrode to know how does we choose the anode and the cathode. Okay, to measure any electrode potential, you have to make a galvanic cell. So you have to make a galvanic cell and choose one of the electrode to be the standard hydrogen electrode, and one of the electrodes will be the unknown potential. Why? You know that we have to connect a voltmeter, and this voltmeter is used to measure the potential difference between the two rods. Okay, and when the voltmeter measures that the potential difference is 3, so could you from this 3 know who is larger than who or who is higher than who? No. So you have to choose someone to be a constant electrode with potential equal 0 and connect it to the other electrode to measure the difference between them. So when you measure the difference between the constant electrode and the other unknown electrode, you will get the potential of the unknown. And that's what we have done to make or to measure any electrode potential for any electrode or any element. You have to make a galvanic cell and connecting the unknown electrode with the standard hydrogen electrode, and by connecting all the galvanic cell you have to measure the potential difference between the two electrodes. And when you measure the potential difference, you will be measuring the unknown potential because the standard hydrogen electrode has a constant value and it is equal 0. Okay, let's read. By forming a galvanic cell from two electrodes, one of them is the unknown and the other will be the standard hydrogen electrode, which has a constant value which is 0. By connecting a voltmeter to measure the potential difference between the two metals or the two electrodes, you will know that the potential difference between the two electrodes is that measured in the voltmeter. So you will be able to measure the electrode potential by connecting it to a standard hydrogen electrode and making a galvanic cell. Okay, what is the standard hydrogen electrode? You know that hydrogen is inert ore with low reactivity. So you are knowing that hydrogen is gas also and it will not conduct electricity. How does you use the hydrogen electrode to conduct electricity in a galvanic cell without being metal, having the ability to conduct electricity. So you will have to make a glass tube which is containing a platinum wire or platinum sheet to be metal with the ability to conduct electricity. So you are using the platinum, it's the inert metal that will conduct electricity without interfering in the potential of the hydrogen. Okay, and the platinum has one benefit also. What is it? The platinum is a metal which has higher tendency to absorb the hydrogen gas. So you will use the platinum wire or the platinum sheet to absorb hydrogen gas through it and to conduct electricity, as it's a metal having the benefit of being metal and it can conduct electricity through the movement of its electrons. Okay, so the standard hydrogen electrode is a glass tube containing hydrogen which are getting on the platinum wire, which has some specifications to be a standard hydrogen electrode. The wire will be with 1 centimeter square, and the pressure, will you add the hydrogen by it, it will be 1 atmospheric pressure, and the concentration of the acid here will be 1 molar. Any change in the concentration or any change in the pressure will change the zero potential of the standard hydrogen electrode. So will you make a difference in the pressure or in the concentration, the potential which is 0 for the standard hydrogen electrode will also be changed. Okay, so you have to know what is the standard hydrogen electrode to make a galvanic cell by it with the unknown electrode potential, to measure the difference between them, and knowing that the standard hydrogen electrode equals 0, so the measured potential is for the unknown potential. Okay, the standard hydrogen electrode contains of platinum sheet covered with a layer of spongy black platinum. Why? Because the spongy black platinum has higher tendency to absorb the hydrogen gas, and the concentration of the acid will be 1 mole per liter, and the pressure of the hydrogen will be 1 atmospheric pressure, so the potential of the standard hydrogen electrode will be 0. And any change in the concentration or in the pressure will lead to the change in the potential, which is 0. So you have to make sure that the specification and the properties of the standard hydrogen electrode is constant to give you a constant value which is 0. Okay, when we allow all of the elements to attach to the standard hydrogen electrode and making a galvanic cell, we were able to know what elements that are higher than the hydrogen in the oxidation potential and which element which is below the hydrogen in the oxidation potential. So the hydrogen could be anode and the hydrogen could be cathode, and any other element will be that, by the way. Okay, the hydrogen will be anode when it connected to an element which is below hydrogen in the electrochemical series and below hydrogen in the oxidation potential. And hydrogen will be cathode when it connected to an element which is higher than hydrogen in the electrochemical series and higher than hydrogen in the oxidation potential. Okay, so we are going to connect all of the elements to the standard hydrogen electrode to measure the electrode potential of each one of them, and making a list of them to connect them to each other, and knowing the electrochemical series or the electromotive series or the chemical activity series. You can name it by these 3 names and you can define it by these 3 definitions. It's a list to arrange the element in an ascending order according to their reduction potential, or they are the element which are arranged in an descending order according to their oxidation potential. So the element which will be with high oxidation potential will be with low reduction potential. It's logic. The element which will be with higher tendency to lose, it will be with lower tendency to gain. Okay, so the arrangement which is called the electromotive series will be an arrangement to arrange element in an descending order from the large to the low, okay, in the oxidation potential. Or it will be the arrangement of element in an ascending order from the low to the high in the reduction potential. Or you can name it the arrangement of element compared to the standard hydrogen electrode. We will get all the numbers and all the values of the oxidation potential or the reduction potential by connecting it to the standard hydrogen electrode. So we can name it the arrangement of any element compared to the standard hydrogen electrode. Okay. Element at the top of the electrochemical series will be with high oxidation potential. So they will be with low reduction potential. And they will be easily oxidized. Okay? High oxidation potential means I love to be oxidized. Okay? So they are easily oxidized and they can act as a strong oxidizing agent. Okay? Element at the bottom will be with high reduction potential and with low oxidation potential. So high reduction potential, it means that they are easily reduced and they are a strong oxidizing agent. Element at the top can replace element which are below them, and element at the top can replace hydrogen in water and in acids. And as the distance between the two elements increase, the replacement will be faster and will be stronger, and the electromotive force which will be obtained from this galvanic cell will be higher and larger. Okay, the electromotive series, you are not able to save it or store it, all of it, but you can name or save some of them. And also you have to know that your exam is an open book exam, so you will not have to summarize all of them in your mind. Okay, if we are comparing between lithium and silver, which one of them will be with high oxidation potential? Also, it will be the lithium with the high oxidation potential because it will be at the top of the electrochemical series. And the silver will be element with the low oxidation potential. So it will be oxidized and it will act as anode. So the silver will be reduced and it acts as cathode, because we have studied at the last session that the potential which will be oxidized, or the electrode which will be oxidized, have to be the anode electrode which will be oxidized at all time. So at all time at anode, oxidation takes place, and at all time at cathode, reduction takes place. So the lithium and the silver, you know that the lithium will be the anode and the silver will be the cathode. I have a question. Had I must to be with an element above hydrogen and with element below the hydrogen? So with your idea, there will be no galvanic cell for two elements which are above the hydrogen, and there will not be a galvanic cell for two elements which are below the hydrogen. And it's wrong. You can make a galvanic cell with lithium and potassium. You can make a galvanic cell with sodium and aluminium. You can make a galvanic cell with zinc and iron. Any element can make a galvanic cell with any element below it, and you will be able to discuss who will be the anode and who will be the cathode. Lithium will be the anode with the higher oxidation potential, and potassium will be the cathode with the lower oxidation potential. So lithium will be oxidized and potassium will be reduced. Also, when you have to choose silver and gold, the silver will be the anode and the gold will be the cathode, because silver lies above the gold in the electrochemical series. So all that properties and all that properties can be applied to two elements which are above the hydrogen and which are below the hydrogen. So zinc can act as anode when it connected to iron, and zinc can act as cathode when it connected to aluminium. So any element in the electrochemical series can act as anode and can act as cathode because all the element will have the oxidation potential and the reduction potential of it. Have you noticed that the oxidation potential of lithium is 3.045 and the reduction potential is the same number but with the opposite sign? So as you are good at oxidation, you will be bad at the reduction. So any element of that will have the value of oxidation potential and the same value in the reduction potential but with the opposite sign. And by the electrochemical series study, you were able to know any element will be anode and any element will be cathode. Okay. In the galvanic cell, the element with higher oxidation potential always oxidized and act as anode, and the element with the higher reduction potential is always reduced and act as cathode. Okay, after that you were able to know at the last session why did we choose the zinc to be the anode and the copper to be the cathode. Because zinc was with the higher oxidation potential, so it has the highest ability to be oxidized, and the copper is with the low oxidation potential, so it was with the higher reduction potential and is the higher tendency to gain and to be reduced. Okay, how does you measure the electromotive force of any galvanic cell in a mathematical way? You will have to study 3 rules to measure the EMF of any galvanic cell. If I give you in the given the oxidation potential of the anode, which will be oxidized, and the reduction potential of the cathode, which will be reduced, you have to add them to each other. Okay? And if I give you in the equation the oxidation potential of an element and the oxidation potential of another, you will be able to measure the electromotive force by making the higher oxidation potential minus the lower oxidation potential, so the oxidation potential of the anode minus the oxidation potential of the cathode, the higher one minus the lower one. Okay. And if I give you the reduction potential of an element and the reduction potential of the another, the two given are with the reduction potential, you have to subtract the higher reduction potential minus the lower reduction potential, so the reduction potential of the cathode minus the reduction potential of the anode. So you have to know the 3 rules as the given of the equation you will be given. If I give you the oxidation potential and the reduction potential each of the anode and the cathode, you will add them to each other. If I give you the oxidation potential of the 2 elements, you will make the higher minus the lower. And if I give you the 2 reduction potential of the 2 elements, you will make the higher minus the lower reduction potential. And the EMF we are measuring have to be a positive value, because the galvanic cell making a positive value when it's spontaneous and when it produces an electric current. How can we use the rules in measuring or in calculating the following questions? Let's see. 2 elements A and B having oxidation potential 0.76 and negative 0.34 respectively. So A will be the 0.76 and B will be negative 0.34. And the 2 given are oxidation potential. So if he asked us to measure the electromotive force, you will have to make the higher oxidation minus the lower oxidation. Okay. Both elements are divalent, so their valency equal to Write the cell expression or the symbolic representation for the galvanic cell formed. Okay. The cell expression we have studied at the last session. We have to write anode and cathode, and there is a salt bridge between them. At anode, oxidation takes place, and at cathode, reduction takes place. You have to choose which element of them, A or B, will be oxidized and which element will be reduced. The element with the higher oxidation potential is the element which will be oxidized. Okay? So A will be oxidized and it will be changed into positive ion. Positive 1 or positive 2 or positive 3 ion. Positive 2. How did you know? Because he tell us before that both of the elements are divalent, so they are going to lose 2 electrons or gain 2 electrons if they are reduced. Okay. B will be changed from B positive 2 into B. And never forget the arrow which represent the direction of the electron flow from the anode to the cathode. How could you calculate the EMF of the cell? You are having 2 numbers or 2 values represent the oxidation potential of the 2 elements. Okay, we are going to measure the electromotive force by making the larger or the higher oxidation potential minus the lower oxidation potential, which will be 0.76 minus negative 0.34, and it will be positive 1.1 volt. Okay, so the last question, does the cell produce a spontaneous current or not? Of course. Why? Because you are getting a positive value in the electromotive force calculation, so it means that the reaction will be spontaneous and it will produce electric current and it can act as a galvanic cell. Let's see the other question. A galvanic cell uses the following reaction: H2, which is changed into 2H positive, and copper positive 2, which is changed into copper 0. Okay, it's clear that some of them is oxidized and the positive charge is increased, and the other is reduced and the positive charge is reduced. Write the symbolic representation. Okay, the symbolic representation, we must to write anode and cathode. Between them, there will be a salt bridge. At anode, oxidation takes place. At cathode, reduction takes place. Okay, which will be oxidized? It's clear that hydrogen will be oxidized because it's changed into positive ion. So hydrogen gas will be oxidized into 2H positive. And copper positive ion will be reduced into copper 0. And never forget the arrow which is representing the direction of the electron flow from the anode to the cathode. Which element is the oxidizing agent and which element is the reducing agent? The element which will be oxidized, we are naming it reducing agent. And the element which will be reduced, we are naming it the oxidizing agent. Okay? Calculate the EMF of the cell knowing that the oxidation potential of the copper is negative 0.34. Why didn't he give us the oxidation potential of hydrogen? Because you are knowing that the standard hydrogen electrode is equal 0. Okay? So when you are going to calculate the EMF, you will make 0 minus negative 0.34 to give us positive 0.34 volt, which can represent a galvanic cell with a positive charge of the EMF. Okay, all students, we're going to make a summary for our session which is. We have started our session by talking about the standard hydrogen electrode, which is a very important task in our chapter. The standard hydrogen electrode is the electrode that we are using to measure the unknown potential of any element, and after that we are going to know the electrochemical series or the chemical activity series and how can we arrange the elements in it. The elements at the top of the electrochemical series are with the high oxidation potential, so they are with the low reduction potential. They will act as anodes and they are reducing agents. Elements at the bottom of the electrochemical series will have low oxidation potential, high reduction potential, and they also always act as cathodes and they are oxidizing agents. We have discussed also that the standard hydrogen electrodes have some conditions must be balanced to be with zero potential, which is 1 atmospheric pressure and 1 molar concentration of the solution of the acid and 1 centimeter square also for the platinum sheet. So the standard hydrogen electrode will always be zero with that conditions. And remember, any change in these conditions will lead to change in the zero potential, so you cannot make use of it in measuring the electrode potential if only they are with the standard properties and the standard conditions, which are 1 atmospheric pressure and 1 molar concentration and 1 centimeter square for the platinum sheet, which is covered from a layer of a spongy black platinum, which will be with higher tendency to absorb hydrogen gas. We have also discussed some problems of the EMF, and you know that the EMF of the galvanic cell must be with the positive charge, because the positive charge of the EMF will make sure that this reaction is a spontaneous reaction and you have converted from the chemical energy into the electric energy. Let's see other sessions in next week.